Alright, so we are doing this problem called combination sum. Let's have a read. Given an array of distinct integers, okay, we are given distinct integers and a target. Return a list of all unique combinations where the chosen numbers sum to a target. Okay, that's why it's called combination sum. We have to find all the combinations whose sum is equal to the target. You return the combinations in any order. The same number may be chosen from candidates in an unlimited number of times. Interesting. Two combinations are unique if the frequency of at least one of the chosen character is different. Okay. The test cases are generated such that a number of unique combinations that sum to target is less than 150 combinations for the given input. So the total answer is not that big. Fair enough. Let's look at this input. Candidates equals to 2, 3, 6, 7, and target equals to 7. So we want 7 as the target. So I can use 2 as many number of times. I can use 3 as many number of times. I can use 6 as many number of times. I can use 7 as many number of times. So one of the cases is I use 2, 2, and 3. Okay. And then one that is this. So 2 and 3 are candidates, 2 plus 2 plus 3 equals 7, or that 2 can be used multiple times. 7 is a candidate and so on and so forth. Okay. So let's see. Essentially, every element I can use as many number of times as I want, and I have to find the all the unique combinations. Hmm. And I have to return those combinations, which is also interesting. So the first is I will add I will exhaust 2, right? And only then I will move to 2, 3. So first I'll say, hey, I used 2 zero number of times. That's one option. Sort of like backtracking, right? So and then I use 2. So first is either I use 2 or I don't use 2. And if I don't use 2, then I will never use 2 again. Like that's the way I exhaust it. So okay, so let's move to whiteboard and see if it makes sense. So one of the examples is, I think I'll take the second example because that is interesting, which is, uh, so the input there is 2, 3, 5, and target equals to 8. So this is what I'm going to do. In 2, 3, 5, I'm going to first try all the 2's, right? So one is I try a 2, which is I have taken 2 and I have to choose from 2, 3, and 5. Or I just forget about 2 and I have to choose from 3 and 5. Okay. So here again I have two options. One is I take 2, so 2 comma 2, and then I am left to choose from 2, 3, 5 yet, or I don't take 2, so that means I'll never take 2 again. So I am 2 and now I have to choose from 3 and 5, and this will keep on continuing. Here again I choose 2, so I have 2, 2, 2, and you know what, I still keep that option open, or I say, hey, I'm done with choosing all the 2's. I'm not going to choose any further 2's. Now you choose from 3 and 5 only. And here, if you do again, you can see it goes 2, 2, 2, 2, and you still have the option to choose from 2, 3, 5. And obviously, you keep track of the sum that you're getting. And anytime your sum becomes greater, you stop that path. So here your sum is already 8. So you can, let's see if the candidates can be negative. Uh, So I see the candidate's value is at least 2. So that means candidate's going to be negative. So once you reach your candidate sum or greater, then you have to terminate that. This will be terminated. So at once you find this 8. And the other part would be, okay, so my sum is 6 from 2 to 2, and I choose something from 3 and 5. And maybe, just maybe, sort your candidates array. I don't know if it is of any value, but that's fine. We may or may not sort. I guess that's okay. So that's one bit, and we keep on doing that. So that's the idea. So we go down one path, right? So we'll go down one path and then we'll backtrack, I guess. We go down this path and then we'll backtrack and then we'll try this other path or something like this. And when we backtrack, you get the gist, right? Then it'll go, then it'll backtrack, then it'll backtrack, and then it'll go here. That sort of a thing. That's the idea that I'm thinking. All right. Let's come back to code and see if we can convert it into some working code. So with that idea in mind, we have to return this list of integers, right? So from this list, we need the capability to be able to, because we're doing backtracking, we need the ability to be able to remove elements from the end. So let's see. We'll first start with a list of integer, and we'll call it candidate, right? Equals to new array list, and we'll also have a bigger list of, I guess, call it result equals to new array list, and the candidate is where we'll have the fun. So are all candidates unique? Yeah, all candidates are unique. I don't know if there's any value. What is the length of candidates? Length of candidates is just 30, right? So it's not that big. So I guess just sort the. I don't know if there is any value, but let's still sort. So arrays dot sort candidates. So we started the smallest one. I guess doesn't really matter, but fine. We'll do, let's say, index equals to 0, and while let's just do this. Just should I call it backtrack itself? Okay, backtrack, and then pass on what else? What exactly? Pass everything. So pass the candidates. firstly index, so which is 0, and then candidates. But then one of the questions would be, do we have to call this backtrack for each and every? Let me think. Okay, every time I have two options, either I take or I don't take. So maybe the first path would be don't take, don't take, don't take, don't take, and then so you go. Okay, first solve for don't take, and then solve for take, right? Fair enough. That way you'll maybe do the backtracking better. Okay, so zero back candidates, candidate. Let's call it current. Pass everything just for now. And okay, so result. I'll still pass result as well. Okay, what's bothering you? What's okay? I don't know. Let's see. So backtrack zero candidates current result and target. Say if you pass everything here, and it's called helper. Okay, I don't like this, so it's called helper, and so your helper function is an index. Your helper function has a candidates array, then a list, a result, and a target. Also maybe current sum, right? So you have two options. One is you take. So when I say two options and you take, no, sorry, first option is you don't take. That is the easier option. There you will call helper index. So one thing is if your index is greater than or equals to candidates.length, or let's say nothing. If this is the case, then what do you do? Nothing, just return. Sure. Yeah. What about the actual backtracking? Like, shouldn't I be removing? Shouldn't I be removing the last element or something? No, not here. Just return. Okay. if you say so. I can't do anything here. Otherwise, there is two options. One option is you do don't take. So don't take is helper index uh, plus one, candidates current result target sum, everything. You just don't take. And the other bit is you take. So when you take, you go keep at index candidates current result uh, the target is always target, and your sum is now increased to sum plus index, sorry, sum plus candidates of index, right? Now I can say something. Now with this logic your sum can also exceed, right? And if your sum equals to target, then you made it. Then you do, obviously you will return, but before returning you'll do result dot add current. Actually maybe make a copy, right? So new array list and pass in this list. Okay, so this is fine. Now this was don't take condition, this is the take condition. And yeah, this will handle when you don't take zero at all, then you have next guy, and so you don't have to loop here, it's already taken care of. All right, back. um Had to fix the headset, but yeah, so what were we talking? Don't take and take. Yeah, so once you get the sum, you add it. If your sum is greater, there's a problem. In the don't take, you don't take. In the take, you take. And once you take and you want to do backtrack, so if you are taking, then you also are gonna do candidates, sorry, the current, and you are going to add this thing, which is sorry about that. This is the candidates of index. And you now, how do you remove from the array list is something I'm not too sure. Uh, I'm gonna use this and assume it does things. Just remove. Okay, let's first run code and fix compilation errors. And yeah, so remove last is something. Oh, not current. Yeah, okay. So let's do Google search Java list interface Java docs. So this is the list interface in Java. Um, there is a remove with the index. Let's see what all different removes it has. Okay, so remove at index, remove object, remove at index. So remove and index is what we'll give. All right. So it's not have remove last, but we'll do remove and we'll give the size of the list, which is -1. Okay, let's see if compilation works. Missing return statement. So after this helper, we'll do return this result. Okay, run code. Seems to work for one of the example use cases. If it works for another, then I'll be more confident. It does. Nice. Submit. And it works. Okay, so essentially we did the backtracking. And the backtracking was for every point starting from the first guy. Okay, let's see one thing. If I did not sort, would it work? I guess so. But let's submit and see. Yeah, it works without sorting as well, right? But it just it seems more pleasant. But yeah. All right, that's the backtracking. You basically, the one option is you don't take, other option is you take. And if you're taking, you add that guy to the candidate array, and then after the thing, you remove it. And once you add that, other thing that you do is you add it to your sum. And obviously, if you get out of the candidates or if your sum is increased, then you have to stop that cycle, stop that path, terminate that path. And otherwise, if you find some, then also you have to terminate that path because no point in adding anything further. And yes, you add that candidate into the result array. All right.